Welcome students. Today we want to understand non-homogeneous equations using method of undetermined coefficients. So the idea is the following. Until now, you have seen y double prime plus p of t y prime plus q of t y equals to 0, right? So this is a homogeneous differential equation because of this term here is 0. So we want to now move to the next step where we have y double prime plus p of ty plus q of ty equals to g of t. So this g of t is not necessarily 0, right? So g of t is non-zero. So such a differential equation is called non-homogeneous differential equation. It's still second order, right? It's still second order. It is still linear, right? But it's a non-homogeneous differential equation. And we want to understand how to find solution to this equation. So for that, we have the following theorem. The theorem is, if you take y double prime plus p of ty prime plus q of t y equals to g of t. So for this differential equation, the solution is given in the following form. It is c1y1 plus c2y2 plus yt. Now, what are these y1, y2s, and yt? So y1 and y2 are solution to corresponding. So y1 and y2 are solution to the corresponding homogeneous differential equation. So you set g of t equals to 0 and then solve for this differential equation. You get two solutions, y1 and y2. Make sure that they are fundamental, right? That the Wronskian is non-zero. Otherwise, they won't represent all the solutions, right? When you are asking about general solution, you should be able to represent all the solutions. So that's why you need the fundamental set. So you know what is y1 and y2 now. What is y of t? Now y of t is any solution to the non-homogeneous differential equation. So any solution to this, yeah. So we don't know yet how to find this. We will basically come to it in a minute. So for those of you who have done linear algebra, please see the connection with the linear algebra. Okay. So let's see the proof of this. The proof of it, this is as follows. So what are we trying to prove? Let's see again that any solution to this differential equation can be written as c times y1 plus c2 times y2 plus yt. So how do we go about it? So let y of t be the solution, be an arbitrary solution to the given dE. Yeah. What do we want to do? We want to find out what we want to find out C1 and C2 such that your y equals to C1 y1 plus C2 y2 plus y of t. Yeah. So this is what solution to homogeneous DE. Whereas this is solution to non-homogeneous DE. Let's see how do we go about it. So define u equals to y minus y. So your yt is also, your y, capital YT is also chosen and then fixed, right? You're not changing yt. So now notice the following. So let's look at U. And if you notice, U is going to be, if you take U double prime plus PT of U prime plus, what is the differential equation? Plus QT of Y. So QT of U. Let's see, what do we get? When we do this, you have U double prime will basically give us what? Y double prime minus Y double prime, right? Plus P of T U prime. So what is P of T U prime? So P of T U prime is again Y prime minus capital Y plus Q of T. U is what? Again, U is Y minus capital Y. So simplify and combine. So we have Y double prime plus P of T Y prime plus Q of T minus capital Y double prime plus P of T Y prime plus Q of T Y. So now this is a solution to the, so Y double prime is a solution to the differential equation. Sorry, your Y is a solution to this equation, and your capital Y is also a solution to this. So what do we get? So we'll get this is equal to G minus G, which is 0. So this means what? Therefore, U is a solution to the homogeneous part, right? Because you get U double prime plus P of T U prime plus Q of T equals to 0. So U is a solution to homogeneous DE differential equation. What? U double prime or Y double prime plus PT of Y prime plus QT of Y equals to 0. Therefore, if y1 and y2 are fundamental solutions, so if y1, y2 are fundamental solutions, or rather let's call it as a set, if y1 and y2 is a fundamental set, then by theorem 4 of section 2.3, sorry, section 3.2. What was this theorem? This theorem was any solution to the homogeneous differential equation can be written as a linear combination of the fundamental set. So this would mean that by theorem 3.2, U can be written as linear combination of y1 and y2. What does that mean? It means U equals to C1 y1 plus C2 y2 for some C1 C2 coming from real numbers. So, but what is your U? Your U was y minus y. So you get equals to C1 y1 plus C2 y2, or in other words, you get y of t equals to C1 y1. I'll write t as to indicate that it's indeed a function of t plus y, which is also a function of t. So therefore, you have proved as required. So let's understand the implication of this theorem. So this theorem tells us how to solve the non-homogeneous differential equation y double prime plus p of ty prime plus q of ty equals to g of t. So how are we solving it? So first, we'll take this as 0 and solve the homogeneous differential equation. So what you do is you solve for it as 0, and then you get a homogeneous differential equation. You solve for it, you find fundamental set of solution. So if y1 and y2 are fundamental set, then you get yc, which is basically as c1 y1 plus c2 y2. Then second is you find any particular solution. So any particular solution for this non-homogeneous differential equation. So you go back and find any particular solution to this, and then the yt equals to yct, the solution for the homogeneous part plus non-homogeneous part. When you add them, you get the complete solution. So yc is called a complementary solution and yp is called particular solution. So this is how you basically go about this. Okay. All right. So let's do a problem and things will become clear to us. So before we go further, we need, well, yc is maybe slightly easier to find, but yp, how do you find yp, the particular solution? So for that, we have the method of undetermined coefficients. So let's see the following. So it is based on, so what is the method of undetermined coefficient based on? Again, you're trying to find the particular solution. Is the method of basically postulating a correct solution for yp and working it out. So you have here, find particular solution for this differential equation. So you're given this and you want to find out yp. Yeah. And you want to find yp in a way that it satisfies this differential equation. And you will just need one yp, that's good enough. So now notice that if you take derivative of exponential function, you get exponential function. So derivative of exponential function is exponential. So this leads us to a postulate that yp should be e to the power 3t multiplied by some constant a. This is why the method is called the method of the undetermined coefficients. So the undetermined coefficient. And we'll find what this undetermined coefficient is. Let's take yp to be this and plug it in the equation. So substituting in dE, what do we get? Y double prime. So what is y double prime here? We get yp double prime is going to be, so yp prime is 3a e to the power 3t. So yp double prime is going to be 9a e to the power 3t. So let's plug this here. So we get what? So we get 9a e to the power 3t plus 3a e to the power 3t minus 2, y is a e to the power 3t equals to e to the power 3t. So now the coefficients must be same. So let's simplify and see what do we get out of this. So take e to the power 3t common. You get 9a plus 3a minus 2a. So that is going to be 9 plus 3, 12. Then you get 12 minus 2, 10. So 10a equals to e to the power 3t. Now exponential is never negative, right? So you can see that 10a equals to 1. This implies a equals to 1 over 10. So we have found out in this case. So what is yp? Yp t is a, which is 1 by 10, e to the power 3t. Now, one may argue, is it really an ad hoc method? And the answer is no. Based on your GT or this part, we will decide how should our YP look like. Of course, with coefficients which are undetermined, and then we'll determine them. So let's look at the next problem. Again, we haven't solved the differential equation completely. We are just going for YP for these solutions because for the homogeneous part, we already know how to find it, right? You find a characteristic equation, solve it, and then get the fundamental set of solution. So YP is the new part, and that's why we are concentrating on YP. Let's look at the following. We have find a particular solution to the differential equation y double prime plus y prime minus 2y equals to cos t. So again, a derivative of cosine is sine, sine derivative is cosine. So we postulate yp equals to a cos t plus b sine t. And see what do we get. So plugging it in the differential equation, what do we get? What will be the y double prime? Yp prime is going to be, so yp double prime is going to be, so let's compute yp prime first. So yp prime is going to be minus a sine t plus b cosine t. Similarly, yp double prime is going to be minus a cosine t minus b sine t. Now plug this in this equation. So we get minus a. So therefore, dE becomes minus a cos t minus b sine t. This is y double prime plus y prime, yp prime, which is minus a sine t plus b cos t minus 2y, which is what? Y is yp in this case. Yp is a cos t plus b sine t equals to cos t. So now we need to equate the coefficients. So let's see. So what is the coefficient of cos t here? So coefficient of cos t is here, cos t is here, cos t is here. So let's add this up. So we get minus a minus a minus 2a minus 2a. So that is going to be, minus a, what is the next thing? Plus b minus 2a equals to 1. Now what about sine? So sine, you can think about that sine exists in this part as well, but with the zero coefficient. So let's compare the sine ones. Minus b minus a minus 2b equals to 0. So let's solve these together. So we get what? So from here, you can see that we'll get, so the first one simplifies at what? B minus 3a equals to 1. And from here you can get b a minus 3b equals to 0. So therefore, let's put this back in one of the equations. So therefore we get what? A equals to minus 3b, and plug it in the original equation, in the above equation. So therefore, substitute this in this equation, we get b minus 3 times minus 3b equals to 1. This gives me b plus 9b equals to 1. This gives me b equals to 1 over 10. Now I plug this back in this equation here to see that a is minus 3 over 10. So what is my yp then? I can now report my yp to be yp is a cos t, which is minus 3 by 10 cosine t, plus b, which is 1 by 10 sine t. So this is how you find the particular solution. Now, let's try to look at the next problem. There's something very interesting happening in this problem. So let's try to do this. Let's take A. Again, we may be forced to conjecture A equals to yp equals to a e to the power t, and let's see why this doesn't work. So LHS is going to be y double prime, which is a e to the power t plus a e to the power t minus 2 e to the power t, and that is 0, right? And that is not e to the power t. So yp is not a to the power t, right? So this will not be a solution. So question is, why did this happen? So why did this happen? Notice, let's look at the homogeneous part. What is the characteristic equation for this? The characteristic equation for this is r square plus r minus 2 equals to 0, which gives me r minus 1 times r plus 2 equals to 0. So this means r equals to 1 or r equals to minus 2. So e to the power rt and e to the power minus 2t are solutions to homogeneous part. I mean, if it is a solution to homogeneous part, then how can it satisfy this? Because no, when you put e to the power t in this equation, it will give you 0, not e to the t. So what shall we do in this case? We will basically consider an alternate solution. So whenever this happens, that e to the power t is also in the homogeneous part, the first step is to consider yp of t equals to a e to the power t. Now let's work it out. A e to the power t, of course, a e to the power t times t. So you need to multiply by an extra t there. So let's see, how do we go about it? So we get yp double prime plus yp prime minus 2 yp is going to be, let's apply this. So a will come out. Now, what is the second derivative of this? Remember, we discussed the Euler's formula. So it's going to be a e to the power t plus 0 plus e to the power t times 2 plus yp prime, which is derivative of this, again product rule. So a t e to the t plus e to the t minus 2 yp prime, so which is going to be at e to the power t, and that should be equal to e to the power t, right? Because it's a solution to the non-homogeneous. So from here, we should collect the coefficients and see what do we get. So let's collect the coefficient. So let's expand it out first. So we have a t e to the power t, and we have what? So a e to the power a e to the power t, this guy and this guy will cancel out each other. All right. So what are we left with? We are left with, there was 2 yp, there's a problem. So now it's okay. So this guy, and this guy will cancel out each other. So what is left out here? A times 2 e to the power t. What is left out here? Plus a e to the power t equals to e to the power t. So we get what? 3a e to the power t equals to e to the power t, which implies a equals to 1 by 3. Therefore, what is my yp? My yp here is going to be 1/3 t e to the power t. So this is your yp in this case. Okay. So again, here, since e to the power t was also solution to this part, we have to multiply it by an extra t. So we can see how to go about. Now let's look at the following problem. Again, y double prime plus y prime plus minus 2y equals to e to the power 3t plus e to the power t. Now separately they have been dealt with, all right? You have separately dealt with y double prime plus y prime minus 2y equals to e to the power t. So this is dealt here. And with e to the power t, you have dealt here. Now you want to add e to the power 3t plus e to the power t. Is there any way out? So to get the particular solution, so we have already found that y double prime plus y prime minus 2y equals to e to the power t implies yp is e to the power 3t divided by 10. And in this case, we had y double prime plus y prime minus 2y equals to e to the power t implies yp equals to t e to the power t divided by 3. So this is what we have found out in the previous step. Then now to get particular solution for this, for dE, let's call this a star. Let me call this as yp1, yp2. You get yp equals to yp1 plus yp2. And what do you get? So 1 by 10 e to the power 3t plus t e to the power t divided by 3. So this is how you get particular solution for this one. Right? So point is, we first looked at simpler ones on the right hand side. Now if we combine them by adding, then you work each one separately, and then you add them up. Now what if you multiply them? So what if you have cos t times e to the power 3t? What should our particular solution look like in that case? So this is a case where instead of, see, here two things were added and then we found out their particular solution was take the individual ones, particular solutions, and add them up. Now what if you have two functions multiplied? And then how do we find out the particular solution? So this is a product. So we already know for the individual ones, y double prime plus y prime minus 2y equals to e to the power 3t. We have already found out yp gives us yp equals to 1 by 10 e to the power 3t. Similarly, for y double prime plus y prime minus 2y equals to cos t gives us yp equals to minus 3 by 10 cosine t plus 1 by 10 sine t. And this is worked out earlier on top here, right? You have worked this out here, right? You have worked out this part here for the cosine t part, and the earlier part for e to the power 3t is worked out here. Now, we want to find out yp of these things multiplied. So we postulate again yp of form a cos 3t, sorry, cos t, my bad, a cos t plus b sin t times e to the power 3t. So we have these additional constants. Constants are coefficients. Yeah, it justifies the name, right? Undetermined coefficients. We need to determine them. So again, we take derivative, taking dE, taking derivatives and plugging back to D, plugging back to given differential equation, you will see that yp turns out to be 9 by 130 cosine of t plus 7 by 130 sine of t e to the power 3t. Right? You can work this calculation out. It will give you a relation between a and b if you basically take yp, this yp, and plug it in this differential equation. So now the question is, how do we postulate what solution it should have? So if the right hand side is sum of two or more terms, we can just add their particular solution corresponding to each term, like we did here. Right? We had, in this case, we had two terms. We basically took yp corresponding to this differential equation equals to e to the power t, and then y double prime plus y prime minus 2y equals to e to the power t, and then we added their particular solution. So we want to basically work out with the individual chunk. So, however, when the RHS is product of two or more terms, we need to postulate a particular solution that is a product of particular form of individual particular solutions involving coefficients a and b. So merely multiplying individual solutions will not be sufficient. So product is slightly more involving than the sum. So let's work it out. So how to get a general form of a particular solution, or rather how to postulate the solution. So again, we have, if we have a y double prime plus b y prime plus cy equals to g of t. Now, depending on g of t, we can postulate various particular solution. So if RHS that is your g of t is a polynomial of degree n, that is, what does it mean? G of t looks like a0 t to the n plus a1 t to the power n minus 2 dot dot dot, sorry, t to the power n minus 1 dot 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 an, where a0 is not 0. Then yp is of form t to the power s times a to the power t0 n. Now note that these coefficients are different. a1 t to the power n minus 2 dot 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 an. You have this extra multiplication by t to the s. What is this s? Where s equals to 0, 1, 2 dot 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 is the number of times r equals to 0 is a root of characteristic equation, is a root of characteristic equations, and where what this a0, capital A0, A1, An are coefficients, are constants to be determined, are constants that need to be determined, need to be determined or found out. However, so this implies if r equals to 0 is not a root of characteristic equation, then s is going to be 0. Okay, just to keep that in mind. Now, case 2, when you have g of t is some polynomial, again, let's take a0 t to the power n plus a1 t to the power n minus 1 dot 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 a0 times e to the power alpha t. If you have this as your gt, then what kind of particular solution shall we take? We will take yp to be, again, t to the power s times a0 t to the n plus a1 t to the n minus 1, the way dot 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 a, this should be an, right, notation wise, an e to the power alpha t, again, where s, so we need to decide what power of t should be there, right, for t to the s, where s equals to 0, 1, 2 is the number of times r equals to alpha is a root of the characteristic equation, is a root of the characteristic equation. Yeah. So if we get if we have a0 equals to a1 dot 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 equals to an equals an minus 1 equals to 0, in that case we get what? We get the case of a e to the power alpha t from one of the specific examples earlier. Now, so we have dealt with two cases, polynomial times exponential. Now, next one is polynomial times exponential times sine or cosine. In this case, if g of t equals to a0 t to the n plus a1 t to the n minus 1 dot 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 plus an times e to the alpha t times either sine beta t or cos beta t, in that case, in both the cases, we take yp of t to be t to the power s again, a0 t to the n. Again, these are the coefficients which are supposed to be determined. Note that this is small a0, this is capital A0. So these are distinct, okay? These are different. An times e to the alpha t cosine alpha t, oh sorry, this is beta, right? Beta t plus, so this whole thing is in the bracket. So this multiplied by this plus t to the s is multiplied to both of it, b0 t to the n, b1 t to the n minus 1 dot 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 bn e to the power alpha t times sine of beta t, where s equals to 0, 1, 2 dot 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 is the number of times r plus r equals to alpha plus I beta is the root of characteristic equation. So this method already tells you what are you taking as the function. The new part is you are trying to find out these coefficients, right? These coefficients here, these coefficients. That's why the name, the method of undetermined coefficients based is basically a meaningful name to have. So summary of this is the method of undetermined coefficient is based on postulating the correct form of the particular solution. It only applies when DE has a constant coefficients and when RHS is a polynomial, exponential, sine, or product of these terms, right? Otherwise, so this is what our method is applicable to. In this case, a particular solution can be obtained similar to the product of these factors, possibly multiplied by an algebraic power of t, which is determined by the roots of the characteristic equation. Basically, you're saying that t to the power s, right? So t to the power s is determined by this s is determined by the roots of the characteristic equation. Determining the coefficient of particular solution is done by substituting in DE and then equating LHS and RHS. So this is the whole process of solving a non-homogeneous differential equation with a method of undetermined coefficient. Note that the method of undetermined coefficient is only valid for the differential equations with what? With the differential equation with the constant coefficient, right? That's what is said here. And I want to emphasize on that fact that the method of undetermined, it applies only to DE with constant coefficients. So what does it mean? It means AY double prime plus BY prime plus CY. Note that this method can be generalized to not just second order constant coefficient differential equation, but to the nth order constant coefficient differential equations. We will see that very soon. Thank you for your attention.